Nice to be back with you. We're about to do a question sent in to us by Tiani. Just remember, you can contact us on 0861 058 2621. Or you can get us on info@learnextra.co.za. Great, let's have a look at this question. And I'm sure Tiani will join us shortly. Now the question
I'm with you.
Tiani, you with us?
Yes.
Tiani, this is a lovely question. It's you've obviously hit it somewhere along when you've been studying or maybe in a prelim. What are your instincts?
It was in the prelim.
In the prelim, okay, great. Now, Tiani, if you look at this, what are your instincts telling you about this question? What did you think to do first?
Well, I thought to do first was to interpret the information given to see what quadrant I am in.
Okay. Now, you agree with me that if you look at it, that 2A, but here we've got A, and there, fortunately, we've got a 2A. So the problem is coming in there, isn't it?
Yeah.
Okay, so right, what did you decide to do? What approach did you take?
Well, I thought I might be in the second quadrant.
Yes, very good call. You looked at this and you saw that it was either first or second quadrant, but this negative was telling you what? If tan is negative, which quadrant must we be in, Tiani? Yeah.
Second.
In quadrant 2. So you were quite right. It would be 2 or 4, but because of this restriction, it would be quadrant 2. So you're quite right, and this would be your angle 2A. Correct. Now, I like to do this. You don't have to. You can also draw a circle. And, of course, what do we know about tan by definition?
It is y over x.
It's the y value over the x value. So if I look at this drawing, do you agree with me? This would be your y, and this would be your x. What do we know about y values in this quadrant?
The y value is positive there.
It's positive, but you got that negative on that 24. Is that a problem?
Yeah, I think it's the x value.
Yes, the negative actually belongs to the x value, so we're going to bring it down to there. It makes no difference where I put the negative, but realistically in terms of this problem, we need to have it on the x. When you write a fraction, it doesn't matter, but it does matter otherwise. So at this moment, we've got a nice little right-angled triangle with two sides known. We would have to find this other side here. Right, so how are we going to do that, Tiani?
We'll use the Pythagoras theorem.
Yes, we're going to use Pythagoras. And Pythagoras says to me that x squared, which is minus 7 squared, added to the y squared, which is 24 squared, has to give me the r squared. Right, so let's just take that off because we don't need it right there. So 7 squared is 49. And if I do this one squared, it's going to be 576, is it? Let me just make sure. I don't want to tell you the incorrect fact. So it's 24 squared is going to be 576. Yes, 576 is equal to r squared. And if we add these, we're going to get 625 is r squared. And to find r, we're going to do what?
We'll square root the 625.
Yes, that's right. We're just going to say the root of 625. Now, do you agree with me?
25.
Yes, it's going to be 25. Do you agree with me that it would be either plus or minus 25, but because we're dealing with the radius, it has to be positive?
Yeah, I agree.
So radius is going to be 25. Right, so we've made some progress, but remember this drawing has to do with 2a, and I'm asking you to find the cos of a. So how do you think we could go about that?
Well, I think we'll use the fact that we know that the tan of a is equal to the sine of 2a over the cos of 2a.
Yes, okay, so what you did is went an algebraic approach. So let's pick it up from there. I think it's not a bad suggestion to look at that. What you did is you said the tan of 2a is equal to the sine of 2a over the cos of 2a.
Yes.
And of course, you know that that is equal to minus 24 over 7.
Yeah.
Right, then what did you do, Tiani?
And then I may be able to know the value of sine 2a, but I think we have to target the cos 2a and then manipulate it to split in terms of cos a.
Yes, you see, you're quite right, but you see, that's your B question. So I'm almost thinking that is the easiest way to go about the question. I would agree with you. But if you're looking over here, that's actually what they want in the B part. So the B part is actually an easier question than the A part. Because the B part, as you say, you just go to your drawing. This is a drawing for 2A. And sine by definition is your Y value over your R value. So it'll be 24 over 25.
Yeah.
So that's really a nice way to get that. But that's the B part. And yes, there's nothing stopping you making it part of your working here and then using it and then in B, writing it out again. But there might have been another way. Any ideas on how we could have done another way? This is not a bad approach. This will work pretty well. But I'm going to suggest something else to you. I'm going to say, look, we want to get cos A. And do you agree with me? We only have facts to do with 2A. So do we have a formula that relates cos 2A to cos A?
It would be 2 cos squared A minus 1.
Correct. That's right. And of course, this is easy to get off this drawing. The cos of 2A is going to be minus 7 over 25. And that's equal to 2 cos squared A minus 1. Now, we want to solve for cos A. And that's not going to be problematic, is it? Because we've got cos squared A there. So what could we do here to get this on its own?
We'll take the 1 to the other side.
Yes, we can take the 1 to the other side. And if we do that, we can see that we can now add those things. So we can put it all over 25. And we can go minus 7 plus 25, which gives me 18 over 25. And that is equal to 2 cos squared A. Now, what would I do to get the cos squared A on its own?
We'll have to divide by 2.
Yes, divide by 2. I'm quite a lazy person with this divide by 2. So what I do is I times by a half on both sides.
Yeah.
It's the same thing, and we're going to end up with 9 over 25 equals cos squared A. Now, Tiani, what am I going to do to get cos A?
We'll have to square root, but I think it will square root it to be plus or minus the square root of 9 over 25.
I'm so glad you said to me, because that's a square, we could get the possibility of a plus minus the square root of 9 over 25, which means my answer would be plus minus 3 over 5. However, what do I know about this angle A?
It is in the second quadrant.
Now, 2A is in the second quadrant, isn't it?
Yeah.
Because they're telling me the 2A lies from 0 to 180. So if I'm going to find out just what A is, do you agree with me? I could divide each part of this expression by 2. So 0 degrees would be less than A, would be less than 90 degrees. So what am I telling you about this angle A? If 2A is in the second quadrant, what do I know about angle A?
It's also in the second quadrant, I think.
Okay, let's think about that. We've got 90 degrees over here and 180 degrees. The biggest it could be is just before that 180.
Oh, it's the first, yeah.
Yes, it's definitely the first. You see, no matter how big it is there, when I halve it, it must be first quad. So in actual fact, because of that information, I can go straight to the positive answer, because what do I know about all ratios in the first quadrant?
Yeah, all the ratios are positive.
Are positive, yes, that's right. So this is a beautiful little question, and it was useful to know the quadrants here.
Okay, yeah.
And it's quite a hard question, this. This is far easier. So I think if I'd been setting the paper, I probably would have put B first and then A second. But then it would have made it that you could use that quite accurately. But I suppose the idea here was to get you to think a bit differently, and there's the way to think a bit differently. So let's go to the B1 and just let's pick it up straight away. I did do it earlier on, but let's just put it over here. The B1 is the sine of 2A. And this one, we don't need to worry about anything. We've already got 2A. And our sine is our Y value over our R value. Right, so now what I'm going to do with you, Tiani, is I'm going to show you an example of the same question where we work algebraically and we don't draw a picture. But I believe that when you do maths, it's always great to draw a picture. Draw a graph if you're looking at it, draw a picture. It just helps you to visualize what the question is asking you. So it's never a bad idea to draw a picture, but I think you could have looked at this question and said, look, I'll handle it algebraically. I won't actually look at what I'm doing, what quadrants I'm in and that sort of stuff. But this one made it a bit more difficult to do that. The one I'm going to do now, you could easily have done that. You wouldn't have had to worry about it. So just to sort of enlarge a little bit on it, let's take a question like this. And let's say I say to you the cos of 2a equals, and let's make it 3 over 5. And let's tell us that 2a is an element of 0 to 90. And of course, that's very good news, because now I'm going to say to you, find the value of, firstly, cos A,
Okay.
and secondly, sin A. Now, I'm saying to you, this one is actually an easier question than the one you asked me, but this one can be done without drawing any pictures at all. So what I can do is I can look at it and I say, well, look, I have expansions for cos 2a. See, tan was limiting, because tan you don't have an expansion for in your syllabus. There is an expansion for it, but not in our syllabus. So what you would do is you'd say, look, if I want to get cos, I know that cos 2a is 2 cos squared a minus 1. And I know that the answer of this is 3/5. And now I can work till I find my a. So I can bring that over, so it's 3/5.
Yeah.
And I can say plus 1 is 2 cos squared a. And that would give me 8/5 is equal to 2 cos squared a, which means 4/5, because I'm going to times both sides by 2, is that. And then, of course, what do we know already? We know that because of this, where's a going to be?
What's A going to be?
Definitely in the first quadrant, you agree? It should be an element of 0 to 45.
Yeah.
So we're definitely in the first quadrant, which means what do we know about this when we square root it?
What?
If we now are going to take the square root of this answer, do you agree with me? We'd only look at the positive square root.
Oh, yeah, yeah.
Because we're dealing
It
in
will
the first
be
quadrant.
2 over square root of 5.
Which then could be 2 over root 5, yes. And of course, you would hesitate to leave that. You might have to rationalize. You know how to do that. You times by root 5 over root 5, which then would become 2 root 5 over 5. Now, just to finish this question up, Talani, I just want to say, what would be different now if I ask you for the sine of A? How would I approach this question differently if it was sine of A? Let's have a look. Do you agree with me? I've also got an expansion in terms of sine for cos 2a. So I could have gone 1 minus 2 sine squared a.
Yeah.
And you see, I wouldn't have had to draw a picture at all. I wouldn't have had to actually do anything more. I could just work straight off this. So I could
you
go
didn't have to
3/5.
find the y value.
Correct. And so this would be a little bit easier because you're working algebraically, and that's always a simpler way to go. So all I'm going to do is quickly work this through. But you can see all I'm doing is isolating my sine squared. So I have 2 sine squared a, and 1 minus 3/5 is 2/5. And if I halve it, I've got sine squared a is 1/5. And of course, what do we know again? It's still in the first quad. So our sine a would be?
The square root of...
Be 1 over root 5, wouldn't it?
Yeah,
and
1
you can
over
then
root 5,
rationalize it if you like. So do you see that it's actually a nice question? You could have handled it algebraically. The trouble was dealing with a tan 2a. A tan 2a is problematic in the sense that we don't have an expansion. There is one, but not in our syllabus. So it makes 100% sense to me to go for the drawing route versus this route, which is an algebraic route. So thanks for the great question. Nice chatting to you, and good luck with your examinations. Phone in again. Remember, everybody, you can contact us.
Thank you.
And you can get us on any of those, the number listed earlier on, or on the info@learnextra.co.za.